What if an AI could do more than just follow instructions? What if it could write its own instruction manual and then rewrite it every time it learns something new? Well, today we're diving into a framework that does pretty much exactly that. It's called Agentic Context Engineering. Let's get into it.
This is probably the fundamental question in AI right now. It's the holy grail, right? We want systems that don't just get stuck in a loop, making the same errors over and over. We need them to adapt, to get smarter, more efficient, and frankly, more reliable with every single task they tackle.
For the longest time, the go-to answer was simple. Just throw more data at the problem. But we're kind of hitting a wall with that approach. It turns out the real game changer might not be what an AI learns, but how it remembers and applies those lessons. This whole idea is called context adaptation, and it's all about giving the model better instructions on the fly, instead of having to retrain the whole thing from the ground up.
But, as you might guess, it's not that simple. This approach has its own set of really tricky problems, which brings us to what we're calling the context conundrum.
So what is context adaptation, really? Okay, think of it this way. It's like giving a chef a new cooking tip right before they start making a dish, instead of sending them all the way back to culinary school. It's fast, it's super flexible, and it lets the AI learn in pretty much real time just by tweaking its instructions, what we call its context.
Okay, so that sounds great, right? But here's where things get messy. Current methods are kind of haunted by two major issues. First, there's something called brevity bias. This is where the AI tries so hard to be concise that it ends up throwing out the most important nitty-gritty details. And then there's the second one, something much, much more dramatic: context collapse.
Context collapse is what happens when we ask the AI to re-summarize its entire instruction manual from scratch every single time it learns something new. It's kind of like asking a student to rewrite their summary of a whole textbook after reading just one new page. Sooner or later, things are going to go very, very wrong.
And just look at this. This is what we're talking about, visualized. That red line shows the size of the AI's memory, or its context. See how it's growing? It's steadily learning, piling on more and more knowledge for 60 steps. And then, poof, it completely falls off a cliff. The AI has basically just given up and condensed everything it's learned into almost nothing. And the numbers here, they tell the whole story. At step 60, right before the fall, the AI has this rich, detailed memory of over 18,000 tokens, and its accuracy is at almost 67%. Then, just one step later, its memory has collapsed to a measly 122 tokens, and its accuracy, it plummets down to 57%, which is actually worse than before it started learning in the first place. It's a total, catastrophic failure. So how do you even begin to fix something like that? Well, the researchers behind this new framework called ACE suggested a completely different way of thinking. They said, what if we stop treating the AI's memory like a disposable summary and start treating it like an evolving playbook? Let's break down the difference, because this is really the key. The old way, monolithic rewriting, is like burning your playbook after every game and trying to rewrite it from memory. It's incredibly risky and leads to that collapse we just saw. The ACE way, though, is more like a careful librarian adding a new page or maybe just updating a single sentence on an old one. It protects all that valuable, detailed knowledge by only making small, targeted updates. And this is what that playbook actually looks like. It's not some vague, high-level summary. No, it's a structured, human-readable guide. It's got specific strategies, helpful little code snippets, and even a whole section on common mistakes and what to avoid. It's a detailed instruction manual that the AI builds for itself by itself. All right, so how does ACE actually build this amazing playbook? Well, it uses this really clever modular system with three totally distinct jobs. Okay, first up, you've got the generator. I like to think of this as the athlete. It's the one actually on the field, trying to get the job done. Then you have the reflector. This is the coach, watching the game tape, analyzing every move to figure out what worked and what didn't. And finally, you have the curator, who is kind of like the team's librarian, taking all the coach's notes and meticulously organizing them into the official team playbook. And here it is. This is the secret sauce: incremental delta updates. The curator never ever throws out the old playbook. It just makes these tiny, super precise edits. They call them deltas. It might add a new strategy, tweak an old one, or delete something that's just not working anymore. This right here is the mechanism that completely prevents that catastrophic context collapse. Now, this all sounds fantastic in theory, right? But does it actually work in the real world?
Let's take a look at the results when they put ACE to the test.
The performance gains are, well, they're pretty significant. For really complex tasks involving AI agents, ACE delivered an average boost of over 10%. And even in super specialized fields like financial analysis, it still improved performance by over 8% compared to other leading methods. These are not small numbers. But here's the kicker. It's not just more accurate, it is dramatically faster. Because ACE isn't wasting time rewriting everything from scratch, the time it takes to learn a new lesson, what's called adaptation latency, is almost 87% lower. I mean, think about that. It learns better, and it learns way, way faster.
And this quote from the paper, man, it just perfectly sums it all up. The ACE framework is so good that it lets a smaller open-source AI model perform at the same level as a top-tier, proprietary production-grade agent. It's a total David versus Goliath story.
And if you want the ultimate proof, here it is. This is the official leaderboard for a really tough benchmark called AppWorld. You can see the top entry is powered by the massive GPT 4.1 model. But the research showed that an agent using ACE with a much smaller open-source model could match its performance. That is seriously, seriously impressive.
So let's zoom out for a second. What does all this actually mean for the future of AI? Why does a framework like ACE really matter?
The takeaways here are pretty huge. ACE really opens the door for AI that can truly improve itself in a way that's scalable and efficient. It makes the whole learning process much more reliable by completely avoiding that catastrophic forgetting we saw earlier. And maybe most importantly, because the playbooks are human-readable, it makes the AI's thinking process way more transparent and understandable to us.
And that kind of leaves us with a fascinating final thought. We've just looked at a system that lets an AI become its own coach, its own strategist, and its own librarian. By creating and constantly fine-tuning its own personal guide to success, it opens up a whole new world of autonomous learning. The real question now is, what will it decide to learn next?